Hi class! No, Hannah, I will not use puns. Anyway, the learning target for today is to understand and use the properties of equilateral and isosceles triangles. Alright, so first we're going to start with little vocab terms. First we're going to start with the angle bisector. We've talked about angle bisectors before. They're a line that divides an angle into two equal angles. So if I have a triangle here, and I draw a line through this angle, then that means, and I say that it's an angle bisector, then that means both this angle and this angle are congruent. Next, median. A median is a line from an angle that divides the opposite side into two equal parts. So if I have a triangle and I drop a median down, then that means this side is congruent to this side. And the last one we're going to talk about is altitude. So an altitude is a line from an angle that intersects the opposite side at a 90-degree angle. So if I have a triangle here and I drop an altitude, then that means that this altitude intersects the bottom side at a 90-degree angle, so it's a right angle. Next we're going to talk about properties of equilateral triangles. First property is all sides of a triangle are congruent if and only if all angles are congruent. First thing I want to mention is if you ever see this phrase, if and only if, it means it works both ways. So you can read it as all sides of a triangle are congruent if all angles are congruent. So if all the sides of a triangle are congruent, then that means all the angles of a triangle are congruent. But you can also read it backwards. If all the angles of a triangle are congruent, then all the sides of a triangle are congruent. So if you ever see if and only if, it works both forwards and backwards. It's a phrase that mathematicians use to show that it goes both forwards and backwards. The second property is from each angle, the angle bisector, median, and altitude are the same line. So remember those three lines that I just showed you? In an equilateral triangle, they're all the same line. So if you draw an angle bisector, it also happens to be the median and the altitude. If you draw a median, it's also the angle bisector and the altitude. If you draw an altitude, it's also the angle bisector and the median. Next, we're going to talk about properties of isosceles triangles. First property is two sides of a triangle are congruent if and only if their opposite angles are congruent. Again, here's the if and only if part. So that means it works both forwards and backwards. So two sides of a triangle are congruent if their opposite angles are congruent, or two angles of a triangle are congruent if their opposite sides are congruent. So a quick drawing of that is if these two sides are congruent, remember these little dashes through the sides mark them as congruent, then that means the angles opposite them are congruent. So we have this angle right here, so the angle opposite it is right here, and then that angle is congruent to the angle opposite this side right here, which is this one over here. So we now know that this angle is congruent to this angle. Second property, very similar to the one from equilateral triangles, is from the vertex angle, the angle bisector, median, and altitude are all the same line. So first, what is the vertex angle? Well, the vertex angle, looking up at this picture up here, is the angle that is not congruent to the others, the one that's in between the two sides that are congruent. So it's this angle right here, and I'll mark it with 2 arcs to show that it's not congruent to the other two. So that angle right there is the vertex angle. So if I were to draw an angle bisector from that angle, then it would also be a median and altitude, and so on. If I drew a median, it would be the other two, and so on. So very similar to the equilateral properties, but very specific. So the angle bisector, median, and altitude being the same line is only from the vertex angle, not the other two angles. Alright, now let's look at some examples. So in this triangle, we notice that these 3 angles, since they're marked with arcs, are all congruent to each other. So since they're all congruent, then that means all of the sides are congruent. Remember from the property of equilateral triangles, if all the angles are congruent, then all the sides are congruent. So that means this side is congruent to this side is congruent to this side. So first, let's try to solve for x. So since all these sides are equal to each other, all we have to do is set 2 of these sides equal to each other, and we can find out what x is. So let's take any 2. I'll just take 2x plus 5 and set it equal to x plus 9. And then solve for x. So subtract x from both sides, and that'll give us x plus 5 equals 9, and then subtract 5 from both sides, and that'll give us x equals 4. So we know x is 4. Now we can use that to find the measurements of all the sides. So we know that side AB is x plus 9, side AC is 2x plus 5, and side BC is 3x plus 1. So we can plug in x into all these, and we'll end up getting 4 plus 9, which is 13, and well, if all the sides are equal, we know that all of them will be 13. So we don't have to do anything more than that, and we can just say they're all 13, but just for the fun of it, I'll plug them all in. So 2 times 4 plus 5, so that'll give us 8 plus 5, which is 13, and 3x plus 1, so 3 times 4 plus 1, 3 times 4 is 12, plus 1 is 13. So all the sides are 13. Alright, let's look at another example. So it says here that triangle ABC is an isosceles triangle. So let's start off and draw a triangle. So we've got a triangle, and it's isosceles, so we'll make the marks. These 2 sides are equal. And B is the vertex angle. So that is the angle that is between the 2 sides that are equal. And then A and C. So we know that AB is 2x plus 6. BC is 4x minus 2. And AC is 3x plus 10. So the 2 sides that are equal are 2x plus 6 and 4x minus 2. So let's set them equal to each other. So we have 2x plus 6 equals 4x minus 2. Let's subtract 2x from both sides to get them together. Gives us 6 equals 2x minus 2. Add 2 to both sides will give us 8 equals 2x. Divide both sides by 2. And that'll give us x equals 4. So now that we know x is 4, plug it back into what we had. So 2x, so 2 times 4 is 8, plus 6 is 14. 4 times 4 is 16, minus 2 is 14, which it should be because we originally said that these two are equal, so they should come out to the same thing. If they don't, you probably did something wrong somewhere. And then 3x plus 10, so 3 times 4 is 12, plus 10 is 22. So those are the measurements of all of the sides. Alright, one more example. So in this problem, notice here we have an isosceles triangle here. So the big triangle we see here is isosceles because it has 2 congruent sides. And we also know that it's got a line going through it that makes it so these 2 angles are the same. So that means it's an angle bisector. So since it cuts this angle into 2 equal pieces, it's an angle bisector. And we learned before that if it cuts the vertex angle as an angle bisector, it's also a median and it's also an altitude. So it's also a right angle here. And also, these 2 sides are equal to each other. So if those 2 sides are equal to each other, because it's a median, that means we can set these 2 sides equal to each other. So 14 is equal to 3x plus 2. And then subtract 2 from both sides. Gives us 12 equals 3x. Divide both sides by 3. And we have x equals 4. Alright, if you have any questions on this, please come see me. If not, please take notes on this entire thing. And I will see you next class. Have a good night.